Hey guys, well today we have another HD01 Dyson hairdryer. So I got this one off eBay. This broken, it doesn't work. I just wanted to go a little bit deeper into the hairdryer. About a year ago, I did this hairdryer and it got really good views, and even a museum in the Netherlands was interested in some of the video footage of the technology and what have you. So great to see somebody use it for education. And I just definitely wanted to go deeper into the HD01 and learn more about it. So in this video, we'll start off with me disassembling the head part, since in a previous video I did more of a minor repair and showed the handle and switches and all and the motor being taken out. And even though I didn't take this apart correctly, with a little bit of patience, hopefully you'll realize that at the end of the video I do show it being reassembled and the correct way to do so. So let's just see what it takes to fix this Dyson hairdryer today. So after I got the wires from the switches and all up through and twisted a little bit, this whole thing does come out. So I'm very impressed by what they did here. And if you look in there, the secret to this thing looks like it twists and locks in. And unfortunately, I snapped the tab off in there on this top side, real similar to these back ones, the way it twists and comes out. Your heating element, the mica band, and all that also looks like it twists and locks in there. If I'm looking at it right, counterclockwise. So you turn it clockwise to get it out. And I actually did, I don't know if it was on video or not, but I did rock it back and forth and bump it, but not nearly enough. That must be a heat sensor right there. I unplugged that early on getting the board out. Well, interesting. And these little, almost like threads right here just past this O-ring. We have an O-ring, or actually, I'm sorry, that's not an O-ring, it is a rubber seal or gasket. But you see the threads there? I chipped that one as well as the actual housing where it latches on. But now we know. Dope. And there's a look at the board. We'll trace all this down, but the AC coming in, you definitely got some resistors and some, like a bridge here and a fuse and a 117-5, so that's a 5-volt regulator. X2 rated cap. The MOSFETs for the heating control, and of course our, I'm pretty sure that's for the heating control, the higher current. All the capacitance is probably for our little brushless motor, little turbine. So Q6 and Q7, of course, are little flat pack type MOSFETs. They're made by IR. So the microcontroller must be this little beast down here. Little tiny chip that we really can't see well without desoldering. So back here with this setup, with a lot of things so they can't touch, I have heat shrink on some things that will be bare. I also have 120 volt terminals that's going to be here. We don't want the ground to touch. And we also have a little ionizer. It tells our input AC is 100 to 130 volts, 60 hertz. And our output is 1.5 to 3 kV DC, so up to 3,000 volts. So that's going to ionize the air as it was coming across. It was just on here like so, ionizing the air as it come across. So just to help with the static. Something we use a lot in industry with film moving too, or paper moving, is static eliminators, which are ionizer. So I've actually never seen one that small, so that's pretty neat. I'm going to use heat shrink because I don't want tape to stick to this mica. This mica band's already flaking off. I'm just going to put some heat shrink around here just to help so nothing can touch those terminals at the bottom easily. Because I am going to power this up. Of course, I still have my motor disconnected, and that's where that ground would be. I'm going to cover up that ionizer so that 3000 volts is protected. And if I cut this on and I have the switch turned on, we get no lights or anything. And I know the LEDs are actually pointing down, but you can see them reflect. They don't come on. And I've kind of drawn out, be careful here. I've kind of drawn out this diagram of how the AC power works, just getting back to the board. And I've kind of went around and figured out that this 117-5 is not getting the voltage to it that it should have. So our output should be our tab here and our pin 2. Our ground should be this pin 1. And so that means our input would be pin 3. And we're getting 2 volts. So that means our output's going to be less than that. Get to the tab. Yeah, we got a voltage drop across it, of course. So about 1.3 volts. So we don't have the DC voltage on this board. Now, once again, we have AC power, 120 volts. And even 160 or 70 volts on these caps. So anything you attempt like this, you're doing at your own risk. And if you're not qualified, you shouldn't do so. But I'm being very careful to not let things touch. You see 160 volts DC there coming off the bus and those diodes. And unfortunately, we got to go to the layer below because we should have this somewhere probably about 6 or 7 volts coming up to this 5-volt regulator. Should be coming through those terminals there. So I'm going to cut this off. Those capacitors are still going to be draining down, but we don't have any AC on this part. So, but if you can see the ring where our push buttons are and our LEDs and all that assembly. Unfortunately, you just can't get to this to troubleshoot without removing this board. So back now, I have soldered and vacuumed off for those two and pulled those after removing some silicone there, removing that header. And I started working my way this way. I've gotten 1 pin. I got 7 more to go on these 8. That top board will actually pop off then. So I'll be right back after we desolder the rest of these on this header. This thing actually works pretty well. This is the last one I got to do. I just put it on there and I put a little bit of upward pressure until I can see the solder start to melt. And when it melts, it'll ease forward. And as it eases forward like so, and the solder starts to ball up, I'll rock it back and forth and try to get all the solder around that pin, like so. And I did learn the hard way that when I try to use my regular soldering iron and that one together, like to heat up a bigger pad, that those tracks, or SER, however they decide to do the design of the temperature control, as it's firing at different rates, I usually have up to 50 volts difference in potential across them on the tip, so you actually can't use them together. Or especially in my case, this room I have an arc flash protection breaker in, and it doesn't like it. Not at all. I want to be very careful not to damage any trace on this side of the board. And there we go. That's a good look at this power board that does the Q6 and Q7. Of course, goes out to our BLDC. And then here's a good look at the bottom of that board that we normally don't get to see either. This surface mount diode right here, D23, does not look good, but it does test shorted. But of course, the catch-22 of diodes around inductors is it looks like it's across that inductor, so it would show shorted even if it was good. So diode check does not work on those. It has definitely gotten hot, but whether it's bad or not, I'm not sure. So I think I'm just going to heat up the soldering iron instead of the hot air. There's so many small components around. I definitely don't want to get hot air around this little PIC 16 chip. I don't want to get heat around a microcontroller anyway, so I'm just going to try to take my soldering iron tip and just knock that diode off and just test it and see. So even though it may not be pretty, I have a 1000 volt, 2 amp Schottky diode or fast recovery diode soldered across here. I did not have a surface mount, but I made this one work. Go to diode mode. If we test it now, we actually get open that way, and we get our diode this way. So that diode that I took off was actually shorted. So I think I'm going to put this back together. I don't see anything else wrong with it, and it's almost impossible to test without either running a bunch of wires and soldering them or just putting it back together and soldering it. So we have everything soldered back in. Okay, so are you ready for something pretty cool? Make sure this board's covered up so it don't touch anything. I have the power applied. I'm just trying to get it so you can see the front board with no AC stuff touching. Look at there. Did you see the lights come on? The reason I cut it on and cut it right back off is because once it does the test, if it tries to come on, I have no airflow across the heating elements. But of course, at least the way I see it at this point, it's hard to test without it because the 120 volts goes through the heating elements as I've shown here and come back to power the board. I'll try to find out and figure out a little more about that before I share a lot of the details. But I've traced out some of the heater and 120 volt circuit. So back now, I am safe. I have all the power disconnected. That's just our board that gives us our cold shot, which I'm not 100% sure if I would have jumped this out or had it pressed. Maybe the heating element would not have come on, but I wasn't sure it power up, if it would have powered up right with that pushed in. So I checked the fuse, which that's 120 volt there coming from the green wire. That 3.5 amp fuse was good. I checked the 168 volts and this part seemed good. I wasn't sure about the regulator, which you can see the diode we added in there. Maybe even from the side combing through, I could see that diode looked like it had gotten hot, but whether it was open or shorted, I couldn't tell. And of course, hopefully I showed it on video. I really couldn't tell when I got to it because I thought it might have been across the inductor and it was showing shorted. But that diode really was shorted, which was causing that issue of our, I'm going to say probably 7 volts or so coming to this 5 volt regulator that gives us our power for basically all of our low voltage controls. The heating element, as we can see here, I'm still not 100% sure what's going on with this small element. I don't know if you can see, but behind that small element is like a bimetallic strip or like a thermal cutout, I'm assuming. But the best I can tell, those are in parallel with each other. And I don't think it's a temperature control because it's done with a microprocessor with this little NTC that I do have to plug back in here that mounts. It's going to mount like so. But that NTC on mine, I'm assuming it's okay. It was reading 82K at room temperature of around 70 degrees Fahrenheit. Just if you're interested in knowing that, on mine, that's how it read. We talked about these thermals here, which they ended up being 184C. And I just kind of drew out the, coming through the power switch, the black wire goes through the thermal fuse, and it's tied to the front of the other thermal fuse. So they're just tied together there in series. It comes through the little element I was talking about that it reads 0 ohms, but of course it's got a bimetallic strip across it, it seems. And it goes to the inner element, which reads 17.6 ohms. Back to our white is coming through this capacitor. It's an X2 capacitor. It is 224K, which is 220 and 4 zeros, or 220 nano, I believe. So at first, I thought maybe this capacitor was like a capacitor dropper circuit that might have been feeding the controls, and I was right on top of that thinking this might be it. It might be a simple fix. And it was, I guess, simple so far, but it was hard to get to on that diode. But I was hoping it was going to be that. But that actually had nothing to do with the issue. So it's actually what comes in across our neutral, the fuse, and comes back to green. That's how the elements are. Across the blue and the white, I was getting 34 ohms, by the way. And even though this element is a little bit confusing, if we'll look right here, it's hard to see because behind the thermal fuse, the inner one does step up and becomes the outer one right there. So that's why it's a little bit confusing. It looks like the inner one starts and you don't see the inner one come back like it's two different element zones. But the inner one does start and go through and comes up here into the outer. And then we have multiple points on the outer. So that's just how they did the heating circuit on that, using the black coming in from the AC power. So the power switch truly does go straight to the element and through, and back out through the green. And as far as I could tell, the green is where it starts hitting that fuse, and the fuse comes off, of course, and you have other things going through. For example, the power supply, which I believe is for the all that I believe is to do with the BODC. Down here, the big caps, and Q6 and Q7, the big flat pack MOSFETs. And of course, these are going to be for the heat control. So it looks like these are T1235H. They're going to be a high temperature 12 amp snubberless triac. I am familiar with solid state relays and triacs used as like heater outputs in the industry. So that shouldn't have been a surprise to me. And also the little small Q6 and Q7 that I was calling MOSFETs for the BODC driver. They seem to be MOSFETs, but looking up, Infineon actually calls these nano intelligent power modules. So I think that's way more than just a MOSFET. Pretty interesting. So now that this switch mode supply here, or DC converter, is working here, it comes through where we desoldered here. And somewhere between like 6 to 7, 8 volts should go to this regulator, I'm assuming, and we should get our 5 volts regulated out. So that's a pretty good look inside. I don't want to take too much longer on video, so I've already got this back ready to go on here. I had some lineup marks, but it actually can only go one way as keyed. But it's got to go like so. So you really can't booger that up. This does go like so. Had a little notch for it. Then that goes like so. And I have some more Kapton tape if I do need it. Our little NTC thermistor there. A little rubber spacer and insulator there. So this is twisted back together, and that's not terrible, but it's not perfect because I did break the tabs, as we showed earlier when I drove this out, when I didn't know that this twisted out of those tabs, front and back. And of course it made it a little bit harder going back because I did break some tabs out. So it's not perfect. Those tabs, it's like a key. It looks like the tube will stay together in the key, and you could actually rotate this together. And of course I broke some of that tab, the locking tab, out on the front without knowing it. So live and learn. But now we know how to take apart a Dyson. It needs like a type of spanner wrench. The only thing I had close by to do was these long reach needle nose. You just gotta be careful you don't go down into the board, because there are some components on the board there, resistors it looks like. But nevertheless, it did still work okay and twisted and locked in. Now the one thing that'll be omitted from video is the 20 minutes or so it took me to do it and still get this board out, because I kept letting it get hung up. As you can imagine, as you go far enough to twist it back in, that board is kind of hard to keep from getting caught up in there. So no sense in making the video longer showing that, but not trying to hide anything. That took a while to get out and get brought in. And pliers like this help tremendously with that job as well. Now we can put these little T4 screws back in that goes over the switch plate cover. I think it's about time to hook this up and test it. All right, here we go. First test. Power's on. No way. I am loving that. I gotta work on that seal. It did pinch right there. So I do have to pop this back off, but I'll do that after I cut the power back off. Cool shot. I was worried about that switch because I was pretty rough on them wires. So, well, that is fantastic. So now we do have some options here as far as cords. I can try to find the true Dyson cord, and I see some for sale on eBay that's really just regular cords, and I guess someone has figured out that a regular cord works just fine. But One thing I realized with the first Dyson I repaired was that cord was nothing but an EMC type filter, or I think it's got a lot of high voltage capacitors in it, and all for just for suppression, you know, noise suppression, because this is a high frequency device. And of course, cutting the load on and off on a heat load like that will make your lights flicker a little bit. So I think that's all the Dyson cord has in that little box that's built into the power cord itself. So I may just buy a regular cord and hook to this, since this is a repair. And it absolutely should be used with a GFCI always. So that arrow lines up, pushes on. So that is a little bit larger where I solder these in temporarily for a test cord. So that's a small #1 Phillips. The rest of these are T7 Torx. Of course, I think these two seem to be T6, so they are a little bit different. One bit of a warning, when you go to put this filter housing back on, you may have to run it on here before you do all this part with the cord. The one I'm using temporarily, if you can see, I did have to miter the corners of it to get it to actually go through there. So not all cords are going to allow you to slide that back on afterwards like the rest of the stuff will. Even the tube is fine going through the plug itself. So all I have to do now is glue my little buttons back on. It looks like it does matter. It's a little bit of an offset on this power button. And the very first Dyson I worked on, I mentioned I think somebody actually glued it on backwards and it wouldn't cut on them. So just keep that in mind. I still was not 100% sure if that was the cause of that one or not. But I've had no issues with that hairdryer since I've done that. I took it all apart and could find nothing wrong with it, and realized when I flipped that on, this one seems to work either way. So it might matter about that, and making sure, of course, that the housing is all the way up, which I didn't know to look for with that first one. That was my very first repair. So well, all I have to do is glue those on, and I'm probably going to do so after I put the correct cord on here, of course. But I'm going to test it a little bit more like it is. I don't know how many of y'all thought maybe this country boy wasn't going to fix that Dyson, but hopefully you enjoyed this video looking inside this Dyson and this repair. I definitely learned something. I hope you did. If you liked this video today, please consider subscribing to my channel. But if you did learn something and enjoy the look inside of this Dyson hairdryer today, please like, share, subscribe, and thanks for watching.